Actually, I spent the last week or this week in Odessa learning Russian, but so if you have questions about where my family lives and what food I like, we can do that in Russian. Everything else, everything else we will have to do in English or French or German. Anyway, so let's start. So when I was preparing the talk, I decided that probably it's a good idea to first start to actually briefly introduce what REST is, because there is a lot of confusion about it. I will go through the next slides fairly quickly, because obviously the purposes of this talk is to discuss about how Symfony can do REST and not how to do REST in general. I'm basing most of this on a very popular blog post by Martin Fowler, and I have a link at the end to this blog post, and I very much recommend that anybody that hasn't read it yet have a look. Anyway, so REST stands for Representational State Transfer. To understand this, somebody created, Ian created a maturity model for REST. And if you read the blog post by Martin Fowler, you've already seen this image. And basically the idea is that if you look at REST, there are certain levels sort of to reach, and only once you reach level 3, you're actually a RESTful API. So let's briefly go through these different levels and see what is different about them. So level 0 is the Swamp of POX. I don't know if you know what the word POX means, but it's a pretty bad disease. So this is not where you want to be. Basically, the idea is if you're at level 0, you're using HTTP, but basically you're just sending sort of, you're sending big chunks of blobs back and forth, and you're not really using any of the actual features of HTTP. You're just using it as a tunneling mechanism. So this is sort of a procedural approach to using HTTP. So SOAP, for example, is an example of this, because in SOAP basically you tell what the operation is, what you want to happen, the error reporting. It's all done inside the actual HTTP message, and not with HTTP headers and so on and so forth. So in the example picture, I fear people at the back cannot see this, but basically the idea is that if you want to, for example, book an appointment at a doctor, you will have an endpoint saying book appointment, right? And you will book that appointment there, and you will get back, some message. You will have to decipher what it means. You don't know if it was successful or not just by looking at the HTTP headers, right? So this is the most simple way, and I hope all of you are already beyond that. Level 1, this is basically what introduction of URIs. So instead of just having some URL, get appointments, for example, you actually have like appointment/1. That would be a unique resource identifier for that appointment, right? So this is a little bit more object-oriented in the sense that you're actually talking sort of about a specific resource, and if you want to change that resource, then you have operations that you can do on them. So you would have, for example, /appointment/1 question mark delete equal 1, for example, that sort of thing. So you can identify the resource, and then you can say, I want to do this on the resource. That's level 1. And that, again, is something that I'm pretty sure most of your applications cover. Now, where it gets a little bit more interesting is at level 2. And this is actually, I would say, what most people think of when they talk about REST. So instead of just always using GET or POST to make your request, you use GET to get the content back about a specific resource, and you used POST or PUT to actually create new resources, to update new resources. You use delete to delete new resources. And this is information that is specified in the HTTP header. It's not part of the message body anymore. You're actually using the HTTP headers, right? And if the server wants to report back if it was successful, it's also going to use the header. So there's the HTTP status code 200, for example, for OK. Or HTTP status code 404 for not found. So let's look at briefly and some more details about the HTTP methods. And this is actually where REST becomes important. So you have these different HTTP methods: get, head, post, put, delete. And these are what is called HTTP verbs. So this is how you say, I want to get resources, or I want to put this resource at this location. So these are the HTTP methods. And there are two aspects that are very important about these. The first one is if it's safe for caching. So if I get my list of doctor's appointments, then this would be using a get method. And by using the get method, a reverse proxy, for example, any kind of proxy in front of it can decide, okay, this is cacheable content because the person is using a get method. Whereas if I do a post, for example, I'm sending new data to the server, it does not make sense to cache that because obviously you want something to happen on the server, right? So that's this column. And then the second one is called idempotent. And what this means is that if the operation can be executed multiple times without having a different result, right? So if I do a GET request, I would expect to get the same response regardless how many times I execute this, as long as the state on the server has not changed. And this is the question of cacheability. But for example, if I do a post, then I'm posting on a collection and I want to write something there. And if since I am with a post, I'm not sending it to a specific location. I'm just saying to the server, here's some data, please store it somewhere. And then usually the server will respond with a new location where to store this. So this is not idempotent because if I send the content first, it will give me one location. If I send the same content again, it will give me a different location as a response. So I cannot expect the response to be, the result to be the same if I execute the operation again and again. With put request, however, it's different. With a put request, I'm saying, please, here's some content, please put it at this specific location. And then again, it doesn't matter how often I execute this, the result should always be the same. That's why put is idempotent. Delete, again, and that is, for example, is a good example, actually, where I often see REST APIs being wrong. So if I do a delete, so I say, please remove whatever is stored at this resource, then again, I should be able to execute that method as many times as I want, and the result should be the same. However, many REST APIs, or what people call REST APIs, they in fact will return a 404 if they don't find the result, right? And that would be different, because then on the first request, when I delete a resource, I would get, okay, I managed to remove this, for example, a 204 response status code, and then on the second time I'll get a 404, and this would be a violation of the REST principles. And what it really is important about level 2 is that this is one of the key aspects that allow reverse proxies like Varnish and so on to operate. And if you violate these concepts, then reverse proxies will most likely give very bad results for your application. So following these principles is very important. The other thing that I talked about are HTTP status codes. So this is the responses. And there are different ranges for these status codes. So the 100 range is for information, and very few REST APIs use this. Example of this is continue. The server can just say, okay, I've got your request, but actually I'm expecting some more information, so please continue. Another one would be code range 200, which is usually used for successes. So for example, 201 is basically the server saying, I received your data and I've stored it as a new resource, so 201. The 300 range is for redirection. So for example, 301 would be, so you're requesting this URL, but actually I'm giving you back a new location because the location has changed. And from now on, you should always use this new location because it's permanently moved. 400 is for client errors, the classic 404. And then 500 is for server errors. So for example, 501 is you're requesting a feature that is actually not implemented. And again, by being able to respond with such semantic information, you don't have to parse the entire response to figure out if the operation was successful or not, and things like that. Okay, now we're going to level 3. Level 3 is sort of the theme Hypermedia Control. And the idea here is that in theory, with a proper RESTful API, you could go to the home page, you get a list of links of all the possibilities that you have from there, all the data that you can receive, all the operations you have available, and then you can just move down to the different features that you want to use, the different data that you want to read. The idea here is that, in a sense, you could write a client that discovers new features available from the API, that discovers or that can automatically detect that URLs have changed. Because it's always navigating through the URLs that are provided, starting from the home page. There are a couple of standards that deal with how to actually communicate these references within the message response. So Atom, HAL, JSON-LD, IANA link relations, these are all different standards that are not specified as part of the REST standard or the dissertation, but that are useful if you're using or if you're trying to be RESTful in the proper sense. So this actually, many of you have heard as hypertext as the engine of application state, or HateOS, or OAS, or whatever you want. I don't know. It's really sort of a very negative sounding acronym. Anyway, it also seems like a very forced acronym, like just to have an acronym, because obviously this is quite long. Anyway, so this is what is considered HateOS. Now, briefly to summarize a little bit about how the REST maturity model relates to REST and the real world. So the REST maturity model actually doesn't cover the entire idea of REST. And I will actually have a few more slides before I can actually start to show you a little bit about Symfony 2. So that's important to know. The REST maturity model does not explain REST fully. It covers most of the important aspects, but not everything. REST maturity level 2 is actually what most people claim or what most people implement when they say, I've created a RESTful API. When in fact, actually, they would have to go to REST level 3 to actually be properly RESTful. And the next thing that's kind of interesting is that I think when REST started to happen, most people said, okay, I'll just add some mod rewrite rules so that you can have nice text in your URLs, and then suddenly it was a RESTful API because you're not saying /appointment/1 anymore, you're saying /appointment/ Lukas Smith's doctor's appointment or something like that. And of course, that's ridiculous. That's not what REST is about. And at REST level 3, URLs in fact shouldn't matter at all anymore. The way that they are constructed or the way that they read shouldn't matter anymore because they're basically, the client is showing you the URLs and sort of the client can automatically detect an URL and just traverse through the system. Now, so that's some more points on it. In fact, actually, the standard of REST wasn't written for just HTTP. It's protocol independent. However, reality is I've not seen a RESTful API not using HTTP. The next important bit, I've also never seen a proper RESTful client either. So the reality is that even though you should be able to automatically traverse the entire website or the entire service from the home page, I've not seen this in reality. Sort of in the sense that going to level 3 is great because as a developer you can look at it and then hand code your clients, but sort of automatically or having a client that automatically does it, I've actually not seen in the real world yet. And the last bit, which is also kind of sad, is that even though most of us use browsers to access the internet, they're actually very bad RESTful clients because obviously if you have a form, you can do a post, but you can't do a put or delete. And actually Symfony 2 actually had the feature to sort of emulate put and delete, but with that you quickly get into trouble with reverse proxies and things like that. So in fact now by default the feature is disabled to sort of do a put or a delete with this sort of hack to enable it to browsers. Anyway, now two more points before we get into Symfony 2 more specifically. URIs. So they identify a resource, and the important bit to understand is that it is an identifier, sort of like in a relational database, you might have a column with your primary key, right? And the representation of that resource should not be defined by the URI. So what you often see is, I don't know, index.html, right? So then you're saying it's the index.html page, but in fact, it should actually be just index, right? That is the URI. The output format that you wanted it as HTML, that is something that shouldn't be part of the URI, because you're basically saying that it can only be represented as HTML, and in theory, it could be, you could generate an image of that resource index on the server and return that as well. And then it would be kind of weird doing index.html and respond with a JPEG, for example. Instead, what you should do for the representation format, you should use media types. And they represent the format. So to get the HTML version of the index resource, you would say, give me /index, and then the content, I want the content type text/HTML, for example. And so with media types, you can describe both the formatting of the message itself, and that would be with the content type header. So in the content type header, you would say, this request has the message body formatted as HTML, as JSON. And the other thing that you can send with an HTTP request is what is called an accept header. And with the accept header, you say, I want to get the response in this format. Or I can deal with HTML, I can deal with images, and if you don't have HTML or images, I'm also willing to accept anything else, for example. And actually, I have an example here. So, for example, you could have an accept header that looks like application/JSON, application/XML, and then the next bit here, the Q equal, this is sort of the level of preference I have for it. Oh. So with this accept header, you would say, I would most like to get a response with application JSON and XML. If that is not available on the server, I'm also willing to accept HTML. And if that is not available, just return me anything that you want, right? And that's a quite interesting bit, because it basically means that the client does not request a specific format response. The client just says, these are my preferences. Please be considerate of these preferences. And basically the idea is that the server can then look how they can actually return that content. So this is sort of a negotiation process. And this is also a key bit of REST, that you use these content types to communicate the formatting and the representations. Unfortunately, there is no standard that actually defines how this negotiation should work. And so this is basically left up to the different implementations to choose how they do this. So the server could choose, that by default it should always return the application JSON, and if it can't do application JSON, it can just return, I can't respond to that, in theory. Or it could actually try to figure that out. And of course, the server can have different priorities as well, and this entire algorithm is not defined. Okay, let's go to Symfony 2 itself. Again, this was quite quickly. If you've not looked into REST before, I'm pretty sure this was way too fast. If you've already dealt with REST, I hope this was a good refresher, and I hope I didn't bore too many people with these aspects. Anyway, time for Symfony 2. So in Symfony 2, we have a ton of bundles that can help you to deal with many of these aspects. However, actually, the last bit that I was talking about, this media type handling, I think we're not at a very good state yet. But I will show a little bit about it, how it works in Symfony 2 in a moment. So basically, there's the REST bundle, which I wrote mostly, which provides just lots of out-of-the-box tools to create RESTful APIs with Symfony 2. JMS serializer bundle. This helps you generate responses in JSON, XML, RSS, and things like that. So basically the idea with the JMS serializer bundle is that you can give it an object graph, so an object with object stored in properties and so on and so forth. And you just pass that over to a serializer, you communicate the response format you want, and you get back sort of a string with that formatting. Next bit is the Nelmayo API-doc bundle. This is an awesome bundle because basically it can automatically generate an API documentation for your RESTful API. Very useful. The Bazinga HateOS bundle is currently under development. It should be done soon, and then it will be very, very powerful. Right now, if you want to create link relations in your responses, the best bundle is the FSC HateOS bundle. There's another small bundle, templated URI bundle, which works together with these two other HateOS bundles to generate templated URI. Finally, there's the Leap Cache Control bundle, which is not directly related to REST, but helps you add cache headers to your responses. And then finally, if you, for example, want to do a RESTful authentication, there's a OAuth server bundle. For the client side, there are other bundles as well. The OAuth bundle is good for authentication, so this is OAuth clients. And then Guzzle bundle is very great if you want to consume a RESTful API. But time for a demo. So there's the Symfony REST edition that a guy from Berlin created. I did a little fork, basically updating it to Symfony 2.3, fixing some issues and adding some features. Yeah. So let's go and look at some code. So the idea, so this is, let's make that a little bit bigger. This little application allows you to create nodes, to edit nodes, and remove nodes. So we can create a new node. We get a list back of nodes. We can remove nodes, and so on and so forth. And of course, we can do the same thing from the client as well. So, for example, I can send a JSON request here. And here I did a post, you can see here, to the nodes collection. In this case, with this simple example, it actually uses the session to store the nodes. We're not actually persisting in a database, just to keep things simple. So I have to pass in the cookie as a header. And in this client, I just basically say with --JSON, I'm basically sending content type JSON. And here it's basically this message. So you can quickly look at the message. So that's just, some JSON string here to create a new message. And then, of course, I can have a look at the message itself. Oops, that was too fast. Let's go up here a little bit. It's a little bit hard to see here. Let's make it a little bigger. So that's the response here. And this part, the self part, this is sort of link relations. So here you're basically saying, if you want to get this again, this would be the URL. You could have a link relation to a collection and things like that. You can, of course, also delete it. So if you want to delete, where do we have the delete? So with the delete, we just send HTTP message with the delete verb, and again we use the same URL. Actually, this time I wasn't deleting the. Let me correct the URL. So this time message 0 is deleted. Okay. So that basically you can interact with this API from the command line or from any other RESTful client, as well as from the web. And let's briefly look at how this is done. So let's scroll up a little bit. Let's actually make it a little bit more bigger. So this is an action inside a controller. And we have a few features here that we're using that are quite interesting. We have a bunch of annotations at the top. And there's these annotations here with query param, with this, I can basically specify some get parameters that I want to be able to support. So I have an offset parameter. The requirement specifies that it has to be, or it's basically a regular expression, so this has to be digits. It is allowed to be null, and I can add a description, limit, things like that. So this is a way both to clearly sort of document the parameters I want to support, but also to automatically add some validation and to also add some defaults rather than having to write them inside the method. So it basically just makes things a little bit more readable, and we'll later see actually how the NelMayo API doc bundle uses this information to inside the generated documentation. Now, in the code itself, this is actually quite simple. Like I explained, we're actually using the session to store all the nodes. Let me scroll up a little bit more. So here, this $nodes, we just get the session. We use array slice to pick out the part based on the offset and limit that was sent in as a parameter. And then we create a new instance of a node collection, and we return that. And if you've, like with Symfony 2, normally what you have to do is to return a response. With this bundle, basically, you can just return a variable, and there's a listener that will automatically return that to a response. Let's briefly have a look at this node collection. So we have a model here. Node collection basically just gets a list of nodes, offset, and limit, and that's it. And now basically, it's a responsibility of the serializer to now figure out how to represent that as JSON. So let's have a look at how that is done. So here, the JMS serializer, you can configure it with annotations, XML, YAML. I think they also support PHP. But basically what we're saying, we have a node collection, and we have a few properties. Basically we're saying the property nodes is of type, is an array of node instances, and we have offset, this is of type integer, and we have limit that's also of type integer. As you can see here, there are actually some configuration options that are XML specific. And let's briefly have a look at how that looks. So if I go to, let's create a node again. So with XML, we configured that the root node should be nodes, right? That's why the top level tag is actually nodes. Then we also configured, let's have a look here again, that limit is an XML attribute, right? So let's change that briefly here to just say false. And if you go back here, then we'll see limit becomes a tag, right? So there are lots of ways that that enable us to sort of structure the response. Actually, I didn't try this before, but let's see what happens. I think that should, yeah, exactly. So now, because we're no longer inlining the node, it actually creates a new top-level node to wrap around all the nodes. And of course, changing these settings have no effect on the JSON, but they allow you to format the XML. Now let's have a look at the node itself inside. So here we're basically just saying we're exposing the message. And if you actually look at the model, we see that the model actually also has a secret, right? And an ID. And we're not exposing those in the response. So let's go back here. You see that we're just exposing the message, right? Not all the other properties. So if you go in here, model node, if we move this, I think by default it exposes everything. Right, yeah, so now we get the secret and the ID returned as well. This is, the serializer bundle is extremely powerful. There are ways you can do virtual properties, so instead of actually having an actual property on the model, it can call a method. You can configure also sort of different strategies. For example, one strategy you can say you can expose properties based on groups. So for example, if the person is an admin, you might expose more information than for a normal user. And you basically just, in the properties, you can then define a group, and then you can find a list of groups, and then this rule basically just applies if that group is activated or not. Yeah, so really there's a ton of features inside of that bundle. Okay, let's go back to our API. Now, what's interesting, actually let's go into the controller. So let's look at the controller a little bit more. So this method that I already showed to you. This is how to get the list of nodes. This is the method to actually get a specific node. So here you can see that this one is called get nodes action. And this is called get node action. And then we just get an ID as a parameter, and then we can return that. We have the new node action. This is basically there to return a form, which is something that a sort of RESTful client normally would need. But of course, if you're in a browser, you want to get a form to be able to enter the data. So you create a method for that. There's another one, post nodes action. This is the method that is used to create a new node. As you can see here, we're creating that new node here based on the form, right? And if the form is valid, actually what we're going to do is we're going to redirect back to the nodes collection. We have edit node, put node, and everything like that. Now, what you might have noticed is that we actually have sort of a naming scheme that is applied to these methods. And if you follow this naming scheme, you actually can generate the routes automatically. So instead of having to manually create all these different routes, they're actually created automatically for you. So if you go to, let's grab for a node. So these different routes that you see here, new node, get, edit nodes, get, etc., post nodes with put, and also here with the edit node, with the get node, you see that it has /node/ID, or the ID placeholder. This is all generated directly out of the controller. So all you have to do to add this to your, here is this line here. Basically, you specify, this is the controller, and then you just specify type REST, and then it will automatically generate the routes for you. So this is a very convenient way to just expose all the methods from a controller. Let's have a look at one more thing. And that is the API documentation. So when you build your RESTful API, you will most likely want to explain that to your customers, right? And this documentation here is automatically generated from the controller. So here we see there's a nodes method here. You see the requirements. So this comes straight out of the annotations. So we see that there's a parameter offset, a parameter limit. We see the default and all of that. We actually have a sandbox here, so we can try it out, like run the request, get a response. So this is a very, very powerful solution. And basically, how to get that is quite simple. Inside your actions, you just have to add an annotation API doc. And for example, then you can also specify the different return status codes that are supported and things like that. So this is a very, very quick way to get a pretty solid documentation for your clients. Yes. Last bit I briefly want to show is how we're getting these link relations. This is actually done by the FSC HateOS bundle. And basically, this also supports annotations, YAML, XML. So in order to get this, go back here, this link relation here, we just have to add this mapping here, saying that we have a link relation, relation is called self, and it should point to a URL. It should use this URL to generate, and with parameters, I can basically say .id. This is going to read the ID property or the getID method from. So if I do get message here, I hope that works. Oops, sorry. Then, as you can see here, it will call the message method instead. This solution is pretty good. However, this syntax is quite simple, so it doesn't really give you all the power that you might want. So for example, in some situations we had the need to have a link relation that needed to call a method to construct a URL dynamically to an external resource, and this only works. This, with the parameter solution, only works for internal routes. This did not work, or does not work yet. And this new Bazinga HTOS bundle will make that possible using the expression language component that's going to be part of Symfony 2.4. So that's going to make things even more powerful. Right. I think I have like 1 or 2 minutes left. So one last thing I would briefly want to show. So the REST bundle comes with lots of different listeners and configuration options. Let's scroll it up a little bit. And you can enable or disable any of them without having to, you can choose what you want to use. So being able to specify these get parameters in the annotations, that's done with the param fetcher listener. The view layer, that's what makes it possible to just return a variable instead of having to return a response from controller. That's done by the view response listener. With the formats, you can enable and disable which formats are supported. Then with the format listener rules, this is the part where sort of a limited content negotiation support that we have. So you can say for this path, I prefer to return HTML. Otherwise, I also do JSON or XML. So here, when we are using this, because of that setting, without having to specify .html, it's going to return HTML because of the order of the priorities here. Another cool thing that I can do here is that in case of an exception, I actually can specify what response code should be returned. So in this case here, if there's a resource not found exception, I specify it should return a 404. Or if there's a doctrine through an optimistic lock exception, I can set the HTTP header for HTTP conflict. The other thing that I can configure is that if I want to expose the message of the exception, because oftentimes the exceptions are meant more for the developer rather than for the end user, and it could be a security issue if you expose the message. And so here you can configure when you want to expose the message. However, the REST bundle in debug mode will always return the full message. So while you're debugging, you get the full message, but when you go to production, end users will not necessarily see the message unless you specifically whitelist the exception here. Allowed method listener, this creates basically, sorry, I wanted this one here. This is what creates this list here. So basically with this allow header in the response, we say that if you go to Symfony REST /nodes, you're allowed to use get and post on this URL. And that's automatically added with this listener here. Access denied listener. This basically by default, if you have a 4 or 3, which means access denied, Symfony will redirect to a form login page, right? And if you have a JSON API, this doesn't really make sense. So with this access denied listener, you can prevent this behavior for specific formats. So with this configuration, it will redirect for HTML and XML, but it will not redirect for JSON. And the body listener, that's the last bit. This is actually what makes it possible for me to send a JSON message directly to Symfony, because by default Symfony will just decode post messages that are form encoded. And with this listener, it can decode JSON, XML, and you can plug in your own decoders to decode custom formats, turn them into arrays, similar to how a form encoded set of data would be decoded to an array by Symfony 2. Yes, so I think I've covered everything that I want to cover. Obviously, there are way more features in all of the bundles than I could possibly show here. But I hope I showed you a little bit how it's possible to create Symfony 2 REST APIs, both the functionality as well as the documentation, and get pretty far into covering the entire REST standard. I think the biggest problems we currently have are with content negotiation. I think ideally this should be part of the routing system, that as part of your routes, you specify this route accepts this media type, this route accepts that media type. Now with the expression language, this might be possible. Right now it isn't. But other than that, I think we have very, very good coverage of the REST aspects in Symfony 2. So thank you.
So who has any questions? Okay.
Hi, Lukas. I was just wondering, I thought you would mention JSON-API.org, and so can we build JSON-API.org compatible server with these bundles?
Yes. Ideally, I would actually like to have more native support for it. So I mean, the key aspect of JSON-API.org and many of these others are just they're specifying how to structure response messages and things like that. So with the JMS serializer, it's possible to create a handler that will generate the proper format. And like I said, I'm actually hopeful that we will actually sort of provide out-of-the-box support for this eventually. But yeah, it's absolutely possible.
But there is no standard.
There's no implementation yet.
Yeah.
No.
Okay, thanks.
Any questions? Okay.
Lukas, hello. Probably I looked into this bundle maybe half a year ago and found that there is no access levels controls in general, I mean. So you need to create tons of controllers and write for access level rights for each action separately. Is this changed?
No, and actually I would say that this is not, there was nothing going to be implemented into the FOSS-REST bundle related to this. Because I think this is, and this is one of the cool aspects of Symfony 2, is that we can combine different things. So for example, the JMS Security Extra bundle can help quite a bit in reducing the amount of code that you have to write. So you just combine that with a, with a security bundle that helps you to do the security checks. And that's entirely possible because, the FOSS-REST bundle does not, have any requirements that would prohibit this. So really, you can combine the REST bundle with all the other bundles out there. So for this case, I would use, for example, JMS Security Extra bundle. Yeah.
Lukas, привет.
Привет.
Как дела? You're great in Russian. At my job, we implemented a REST service, and I have a couple of questions. Some of them, machine-to-machine client discovery. Is it really? It is make it in real. I mean, we have HTOs, we have Hypermedia as a state, machine state, to change machine state. And there is a big trouble how to create a client for use that HTOs.
Yeah.
Have you any ideas? It is real?
So right now, indeed, there are no good solutions around PHP for doing RESTful clients. The Guzzle library is already a good start. It at least does all the communication part. And actually, I was talking to Adrian and William. They're the people that are working on the HateOS features. And I'm hopeful that they will also create a client library to do the deserialization. So actually, JMS Serializer does support deserialization. So you can not only serialize to JSON XML, you can also deserialize. But of course, it would be great to have some handlers that are more aware of the semantics of how
to follow links and
exactly.
templates.
So right now, there is no solution that I'm aware of. But actually, I think it's not that hard to create it. So especially with JMS Serializer, it should be very possible to do. But it's, I think it will take 2 weeks maybe to work on something like this. But it's definitely possible. And maybe one more thing that I actually find quite important to specify, because you're talking about machine-to-machine communication. I would highly recommend to use XML for machine-to-machine communication and not JSON. Because the problem with JSON is that if you want to change anything in the way you respond, you basically have to break backwards compatibility. So if we look at the XML example here, so we turn XML here. So as you can see here, we have a node tag here because we're inlining, right? And in theory, this API could be that I can just return one node, right? And with JSON, I would probably then have a key node something, right? Node is something. But if I want to then change that to return many nodes, I would have to break backwards compatibility with JSON. With XML, I just add another tag. So classic example, you have a web shop, you're selling your products only in US dollars. So you have a price tag, and you just have a single price tag. And now you want to actually support different currencies. With JSON, you would then have a prices key, and your API would be broken. With XML, you can just keep going without breaking your API at all. Just clients can upgrade themselves to also handle the different currencies, and everything keeps going. So that's why I think actually for machine-to-machine communication, XML is much better. For machine-to-browser communication, JSON is just very convenient because obviously browsers have very good support for JSON.
I agree about XML. We decided to use it. Okay. Other question is about content type negotiation. Why it doesn't work in real world again?
Well, so one of the problems, of course, is that most developers are lazy, and actually being a lazy developer is good. So, for example, when they want to test something, they just like, just like I'm doing here in the talk, I'm just adding .xml to show you that this is the XML response. Of course, the proper way for me to do this would be to go here and say, instead of dash, I will do accept application slash XML, right, to get an XML response. And that's one of the problems, like people just like being able to just add it to the browser URL, and like I said, browsers are just very bad at being good REST clients, and there's no convenient way. So I think a lot of people are just lazy about it, right? And actually this, being able to add .xml, this is a configuration option, you can disable that as well. And the other problem is that, yeah, we just did not spend enough time to implement it properly, and the challenge is, it's just a considerable amount of work to implement it properly. And again, there's no standard for doing it, so that makes it even harder. Yeah, so for the most part, I think, so the negotiation you can do quite simple, right? Because in most cases you can say, okay, this is my API, and I'm just supporting this one content type. Either you accept it or you don't, right? And then
your problem was the client.
Exactly, and then things become much simpler, and this is sort of the REST bundle sort of implements that, a little bit more advanced, but more or less at this level, right? But what would be more interesting is that you say, I have a route with this URL pattern, and this is the route that should go to that controller for generating images. And for the same pattern, this is the controller that should handle returning PDFs and things like that. So this would be proper content negotiation on the routing system. And this is something that we don't have yet. But I hope that with the expression language, we now have the power to configure routes so flexibly and to embed sort of the logic for doing the matching that it becomes possible with Symfony 2.4.
Okay. And last question. We in our project we decided to create custom media type to make true maturity. What is your vision? Should we use one media type general for the application, or each resource might have a different one?
Ooh, I think the question to ask, or the answer here is really, you have to look at your customers, the people that are using the API. If you think that you provide a benefit by doing this, do it. Of course, if you have different media types, you will make their life potentially more complicated as well.
But client side will...
But as soon as you do versioning in your API with media types, which is the proper way to do it, then I would use one per resource, because otherwise, if you increase the, otherwise you always have to sort of increase the version of your entire API when you're just changing a single action, right?
Yes, I agree. Okay, I have a lot other small questions. Nice to talk to you. Thanks.
Привет, Lukas.
Привет.
Thanks for your talk. Just a quick question from me. You didn't touch in your talk, in your topic, question of performance. So, would you recommend to use Symfony 2 with all bundles on high-loaded projects?
So the number of bundles does have a little impact on the performance, but the impact is quite small. Now, what I've seen some people do for their REST APIs is that actually they create a separate application with a reduced set of bundles, reduced set of configuration. And it's not necessarily the bundles that are creating the overhead, but the number of listeners that are creating the overhead. So of course, every listener that you activate has a performance impact. However, if you do your REST API properly, then at least for most of your GET requests, you can do pretty good caching, right? So this reduces the load on the server significantly. So if you really follow the REST principles, yeah, you will most likely not have performance problems. Of course, there's some things that you might not want to cache, like for example, search queries, because there can be so many different search queries that you would overload your cache. And of course, for these, then it becomes a challenge. But overall, I've not seen that the Symfony itself is a problem. Most of the times, the performance problems more come from the database that you interact with. So if you look at the response, let's say you have a pretty good API, it would be 50 milliseconds response time, then I would guess that probably 30 milliseconds of that would be database interaction and 20 milliseconds would be Symfony. So I think you have to look more closely, you spend more time on your database than on Symfony optimization.
Thank you.
Any question? No? Thanks, Lukas. Oh. Just one question, stop.
Hi, Lukas. My name is Taras. I have one question about API versioning. When we launch one service, we have first version of API. We update this service and launch two version of API. How we can give to our developers two versions of documentation for this API, or we use some prefix in URL, or we create some domain. How your recommendation?
So obviously, like I explained before, ideally if you do versioning, you do it with media types. Most people don't. Unfortunately, they use URLs. But if you use URLs, it's actually easier because an LMIO API doc will work quite properly then, and for the documentations. With media types, it's not as good yet, which is very sad. Obviously, having a separate application can make your life a little bit easier, especially if you need to do some because some of the aspects, for example, in the REST bundle are global configuration options. If you change those in your new version, then that becomes a problem. Then sometimes, obviously, a single controller will not be able to handle both versions. The serializer bundle is quite good. With the serializer bundle, you can actually also do annotations that are version specific and things like that. But it really depends on how different your two different versions are. Generally, I think too many people are afraid to have multiple kernels in their Symfony 2 application. I think it's not a problem. You can have many kernels, separate kernels for your different API versions. I think that makes sense in some cases. In many cases, in my experience, you can do it all with one application, and then my API doc, like I said, if you use different URLs for your different versions, works quite well already. If you use media types, it doesn't work well.
Okay, thank you. And then one question more. Sorry. So, if can we develop two versions of API in one bundle, or we need to every time create other bundle?
Like I said, I think it's possible. So you can in your controller, if you need to add some specific features, you could check what the version is and do some additional tasks. I think it's possible. Sometimes, however, I think it's going to make your life a little bit confusing for maintenance because you have then so many if statements in your controllers, and ideally you should have maybe 1 or 0 if statements in your controllers. So I think if you can handle the differences in the API by just different configuration in JMS serializer, I would most likely use the same controller for both versions. The second you start to have different logic for the different versions, I would probably create a separate controller.
Okay, thank you very much.